So yeah, thank you so much for having me. I'm excited to be able to join you all from out here in Walla Walla. My 6-year-old has been homesick from school for the past 3 days, so my brain is a little bit mush, but I'm happy to be here talking to you about this. And yeah, as Lynn said, I am here this evening because I am the author of a book that came out, gosh, about a year and a half ago now, although that seems hard to believe, that's about how we know what we know about bird migration. And so I spent about 2 years of my life immersed in this topic. I read more scientific papers than I could possibly count. I talked to dozens of scientists, not only ornithologists, but a surprising number of computer scientists and engineers and folks like that. I joined a few of those ornithologists in the field to be there in person when they were carrying out their research. And I feel really privileged that it's part of my job to tell the stories of the scientists who are profiled in this book. I still feel like they're the real experts, and I'm just here trying to bring the amazing things that they're doing to a wider audience. And it's a really fun job to have because there are so many good stories to tell about bird migration. So these are just a few of the amazing migrators whose stories appear in my book. On the left, this bird is called a bar-tailed godwit. These birds make the longest known non-stop migratory flight of any bird in the fall. They start out in Alaska and they cross the Pacific Ocean without touching down and end up around New Zealand, which is phenomenal. In the middle, we have a bar-headed goose. These birds make what is probably the highest altitude migratory flight when they pass over the Himalayan mountains as they travel back and forth every year. And in the upper right, this little guy is called a blackpoll warbler. These birds, to get from New England down to their wintering grounds in northern South America, instead of flying along the coast, they just launch themselves out and spend 3 days flying over the open water of the Atlantic Ocean, which maybe sounds less impressive than the bar-tailed godwit going all the way across the Pacific, but a godwit is about the size of a football, and a blackpoll warbler weighs about the same as a ballpoint pen. So it's really just astounding. But for me, what fascinates me just as much as what migrating birds do and how they do it is how we figured all of this out. How do we even know that this is happening? So that's what my book is really about, and that's what I'm here to talk about this evening. Before I dive into that, I want to really quickly just give a little more background about myself and how this book came to be. So before COVID, I was actually working full-time for the American Ornithological Society. It is a mouthful, which is a professional society for bird scientists. They put on an annual research conference. They give out grants to fund research projects, things like that. And they also publish 2 peer-reviewed journals, which are what you see here, where scientists would publish reports on the results of their research. My role with them, I was their communications person, so I wore a lot of hats, but one of my jobs was to promote the new research that was coming out in these journals, to write press releases and things like that. So I spent a lot of time reading scientific papers. And I don't know how many of you listening this evening are familiar with the structure of a scientific paper, but they all follow the same basic format. So if you already know this, forgive me, but they start out with the introduction, where the researchers talk about kind of what question they were trying to answer and why it's important and provide some context. And then there's the methods, where they talk about the procedures that they followed, give kind of the step-by-step of exactly what they did to collect their data. And then there's the results and the discussion, where they talk about what they found and why it matters and where we might go from here. And so I was reading all of these papers, and I kept getting sort of sucked into and fascinated by the part that I think a lot of people skim over to get to the good stuff, which is the methods, the how. I didn't know, or if I had learned in my undergraduate ornithology class, I had forgotten, that you can study bird migration using weather radar. You can study bird migration by putting out microphones at night to passively record the calls of these birds as they fly overhead, because most songbirds migrate at night. We'll talk a little bit more about that. You can study bird migration by analyzing rare hydrogen isotopes in bird feathers. We're not even going to get into that this evening, but that is just wild. It still blows my mind every time I think about it. And so when the pandemic started, I was part of that statistic of all of the women who left their full-time jobs because they had caregiving responsibilities. And what I ended up doing was I decided to write a book proposal based on this idea of how, like the methods behind bird migration research. And so that is what turned into the book that came out last year. So I cover a lot of ground in the book. This is the table of contents. Basically, the structure is I just went chapter by chapter through each of the major methods that scientists have come up with to figure out where birds go. Beginning with the early years of scientific bird banding in the very beginning of the 20th century. I guess not necessarily everyone in this audience is bird people. So bird banding is when they put little numbered metal bracelets on birds to keep track of them. And then going all the way up through the latest like high-tech advances, like high volume genomic sequencing, that sort of thing. But this is way too much to cram into a fun 45-minute book talk. So when I first got asked to come up with a talk that I could give to promote the book, I decided that the most fun thing to do would be to zoom in on just 3 of my favorite stories from the book and share those with you. So that's what I'm going to do this evening. I'm going to talk about 3 of my favorite migration innovators who I learned about in the course of researching this book and what they did. And then I'm going to wrap up by talking a little bit about why all of this matters for bird conservation. And my hope is that you will come away from this talk with a new appreciation for all of the hard work and creativity that went into uncovering every gee whiz fact that you might hear about bird migration. So the first tactic for figuring out what migrating birds are doing that I want to talk about is one that I had not even heard of before I started doing the research for this book, and this is called moon watching. So, as I mentioned, most songbirds migrate at night. There's a lot of theories about why that might be, less predators, calmer air. But this means that if we want to observe their behavior while they're migrating, we can't just look up and see them, because not only are they pretty high up, but it's dark outside. So now we have all sorts of tools like radar and satellite telemetry to help us spy on these night migrating birds. But before any of that technology was developed, this guy, whose name was George Lowry, came up with a really clever way to do this using just a telescope. George Lowry was born in Louisiana in 1913, and he was fascinated by birds from a very young age. In 1936, he finished his master's degree from Louisiana State University in Baton Rouge, and he stayed on there for the rest of his career as an instructor and an ornithologist, and he helped found LSU's Museum of Zoology. Now, being an avid birder and living along the coast of Louisiana, George Lowry would have been very familiar with the phenomenon that birdwatchers call migratory fallout. So to explain it briefly, a lot of birds in the spring, when they're migrating north from Central and South America, they fly across the Gulf of Mexico. And depending on the weather conditions and on what's going on, sometimes when they make it across the Gulf, they basically fall out of the sky en masse at the first. By the way, if you hear thumping, I'm sorry, my office is right below my 6-year-old's bedroom. So that's my 6-year-old going to bed if you can hear thumping in the background. But anyway, these birds, they're flying across the Gulf of Mexico, and if the weather is bad, they basically fall out of the air en masse at the first bit of land that they come to. So in the first like grove of trees behind the beach, it will just be, the branches will just be dripping with every conceivable species of migratory songbird. It's a really amazing phenomenon. And although there really wasn't any way to prove it at the time, a lot of ornithologists in the early 20th century, George Lowry included, thought that it was likely that migrating birds crossed over the open water of the Gulf of Mexico on a regular basis, that this was just a normal part of the cycle of bird migration. But then in the 1940s, a biologist named George Williams, both of the people in the story are named George. I'm very sorry, it was a popular name for mid-century biologists. But so now George number 2, George Williams, comes along and says, hang on, this doesn't make any sense. Why would all of these birds choose to fly over hundreds of miles of open water when Mexico is right there? Basically, he was like, guys, this is where they've got to be. I know no one sees these birds there, but we're just not looking hard enough. Now, George Lowry, George number 1, who had seen the admittedly circumstantial evidence of trans-Gulf migration with his own eyes in the form of this fallout phenomenon, was really annoyed about this and really determined to prove George Williams wrong and prove that large-scale trans-Gulf migration was a real thing. And so he started thinking about how he might do this. And he remembered some quirky ornithology papers from the very beginning of the 20th century, where folks had reported looking at the full moon through a telescope during bird migration season and being able to see the silhouettes of these night migrating birds passing in front of the moon. And he thought, now that's interesting. Maybe I could do something with that. Now, luckily for George Lowry, there happened to be an astronomy professor at LSU also at this time who was an avid bird watcher. And so Lowry and this astronomer, they put their heads together and they came up with a set of equations that would let Lowry take a raw count of how many birds he saw passing in front of the moon in a certain amount of time and do some math and turn this into an estimate of the total number of birds crossing an imaginary 1 mile line on the Earth's surface every hour. This sounds kind of abstract, and it is, but what this boiled down to was it would let Lowry directly compare how much migration was happening in one time and place with how much migration was happening in another time and place. And there had never really been a good way to do that before. Lowry called this the migration traffic rate, and he thought that with this, he finally had a tool to demonstrate the volume of birds that were passing over the Gulf in spring. So April 1945, George Lowry packs up a telescope and boards a ship heading across the Gulf of Mexico for a port on the Yucatan Peninsula. And the very first night, they're out, on the water of the Gulf. He goes up on the deck, he sets up his telescope, points it at the moon. He's so excited. This is his big moment. This is how he's going to prove George number 2 wrong. And he looks in the eyepiece. George Lowry did not have any experience at sea, and he had failed to anticipate the fact that when he looked through the telescope on the deck of this boat, the moon, as seen through the telescope, would be bobbing up and down with the waves, making it impossible to get an accurate bird count. But George Lowry was not a man who gave up easily, so he waited until the boat docked in the Yucatan, and he tried again. And pointing his telescope at the moon rising over the Gulf, he tallied 12 birds in about 45 minutes. That might not sound like that many, but it worked out to more than 3,700 birds passing over a 1 mile line extending out into the Gulf every hour. So George Lowry had just collected the first hard numerical evidence that trans-Gulf migration was real. So he knew he was onto something. He was just getting started. He's like, I could do a lot with this tool. And his next idea was that he could scale this up and he could recruit volunteers from across North America to collect this type of data. But this was going to be a huge undertaking. He wanted to look at migration patterns at the scale of the whole continent for the first time. This was not going to be something that he was going to be able to do alone. And luckily for him, an enthusiastic young graduate student named Bob Newman arrived at LSU right around this time. So this is George Lowry again on the left and Bob Newman on the right. Clearly, Bob Newman was not an enthusiastic young graduate student when this was taken, but in the pre-smartphone era, it turns out like a lot of photos of people weren't published until they got famous later in their career. So you'll have to use your imagination. Now, like Lowry, Bob Newman arrived at LSU as a grad student and ended up staying on for the rest of his career. And these two men formed a working partnership that lasted until Lowry's death in the 70s. Newman also passed away decades ago, so I did not get to talk to either of these men when I was working on my book, but I did talk to an ornithologist in his 80s who studied with both of them. And my impression that is in a lot of ways, George Lowry and Bob Newman could not have been more different. They were sort of the odd couple of ornithology. Lowry was an old school gentleman naturalist who wore a suit and tie for field work and organized expeditions into the jungles of South America to gather more specimens, for his museum. And he was a workaholic who would go home to eat dinner with his wife and then sneak back into the office in the evening to get some more work done. Bob Newman was a jokester. He had a reputation for his sense of humor, which is going to be relevant in a moment. And he also approached problems a lot more like a modern scientist. He taught himself statistics before that was a common skill for zoologists. And he also made it a personal mission to keep up with the latest bird migration research being published all over the world. And so together, these two men came up with a plan to collect a snapshot of migration activity across the entire continent during a single week in October. No one had ever tried anything like this before. This was before the internet. This was basically before computers. There would have been a few primitive computers in the US at the time, but these two guys did not have access to them. And so the way they went about this was they spent literally up to 12 hours a day handwriting personal letters to hundreds of volunteers around the country, targeting local bird clubs and Audubon chapters, explaining the goals of the project and what would be required of data collectors and the special contribution that they would be making to science. And they really wanted to make sure that they got high quality data back, so they even went as far as printing up a how-to pamphlet to mail out to all of their volunteers, complete with some advice on how to stay comfortable for long stints of staring up at the sky. This is an actual pamphlet, or excuse me, an actual illustration from one of their how-to pamphlets. I mentioned that Bob Newman was known for his sense of humor, so I can't decide if this was meant to be funny or if it was just the 50s, but my jaw definitely dropped when I found this. Excuse me. My voice is going a bit, bear with me. So finally, in fall 1952, telescopes swung into action across North America. Soon, observations were flooding in. Paper data sheets mailed in from every part of the country stacked up higher and higher and higher on their desks. I think I skipped over the numbers, but they had recruited thousands of people in hundreds of locations from Canada all the way down to Panama to do this. And soon, Lowry and Newman realized that they had a problem that they should have thought of beforehand, which was how they were going to analyze all of this data. Again, no computers. This was before most zoologists had any training in statistics. They now needed to calculate the average direction and volume of bird migration from all of these hundreds of locations. And because they wanted to look for connections with the weather, they had to look up data on temperature and wind and the movement of cold fronts for each of those locations in printed books of weather records. And then they had to depict all of this on easy to interpret maps, which they would have to draw by hand. It took them 14 years. Finally, in 1966, their magnum opus appeared in the ornithological journal, the Auk, which is one of the same journals that I would be working for about 50 years later, which is fun. They titled it A Continent-Wide View of Bird Migration on 4 Nights in October. And it was full of page after page of these painstakingly crafted maps where they used different colored arrows to indicate the volume and direction of migration at all of these locations across the continent on the nights of October 1st through 4th, 1952. You can do moon watching for a couple of days on either side of the actual full moon. And you could see in the Midwest and East these massive migratory flights that spanned multiple states with reports from many different locations that were really consistent in how many birds were passing over and what precise direction they were heading. And you could also see how favorable winds and the movement of cold fronts both affected the patterns of migration across the continent, with the heaviest migration occurring in front of advancing cold fronts. And this is kind of old news to birders now. Birders know how to look at the weather forecast to guess when the next big wave of migrants is going to come through. But this would have been very new at the time. Like, to see this at such a large scale would have been mind-blowing. I feel like today, when we're so used to like satellite imagery and stuff like that, it's almost hard to imagine how amazing it must have been to see these migration patterns laid out at the scale of the whole continent. So this paper was a blockbuster. It was 40 pages long, which is very long for a scientific paper. It influenced studies of migration for years to come. It was also the last moon watching paper that Lowry and Newman would ever publish together, because all of this hard work was about to be made pretty much obsolete by the rise of a new technology, and that was radar. So this image was taken from the National Weather Radar System, the same one that you see images from on the Weather Channel, showing where precipitation is in the form of these green and orange blobs. And you can see some rain on this map over on the East Coast, but all of those round blobs down the middle of the continent are birds. Now, They generally filter migrating birds and other distractions out of the radar images that they use for TV weather reports. But birds actually show up really well on radar. And so during migration, as these big waves of birds move across the continent, the only reason they show up as these round blobs is because each of these blobs is the field of view of one individual radar station. And as all of these birds lift off in the evening for their night of flying, they just completely saturate the field of view of the individual radar stations. It's really quite something. But when people first started using radar in an organized way, it hadn't really occurred to anyone yet that they might pick up birds. They weren't looking for birds, and they weren't looking for thunderstorms either. They were looking for Nazi planes. So I'm going to get a tiny bit technical very briefly. Radar stands for radio detection and ranging. And the way that it works, as you can see depicted here, is that a special radio transmitter beams out radio waves. Those waves bounce off of whatever objects are out there, and some of that energy is reflected back to the radar equipment. And how much energy comes back and the angle that it comes in at tells you something about the size and distance of anything that's out there. So it's basically like sonar or echolocation, but with radio waves instead of sound waves. British scientists had figured all of this out by the 1930s, and so by the time World War II got going, they had built a network of radar stations up and down the British coast as an early warning system for any planes coming from the European mainland. But pretty much as soon as these radar stations were operational, they started picking up some weird signals. Unlike planes, which, as viewed on radar, plodded along at pretty consistent speeds and trajectories, they were seeing these weird little blips that appeared and disappeared and changed direction at random. Supposedly, at one point, a red alert was sounded and British fighter planes were urgently ordered into the air to intercept strange signals heading across the English Channel, only to find nothing there. And so the exasperated radar operators started calling these mystery signals radar angels. I'm sure you all can see where this is going. So while all this was going on, this guy had been teaching science at a secondary school in Devonshire in southwestern England. His name was David Lack, and he didn't know it yet, but he was about to become the father of what is now known as radar ornithology. By the way, David Lack was a young man at the time period that we're going to be talking about. This is another case of there aren't any published photos of young David Lack, so use your imagination. David Lack, like George Lowry, had been interested in birds from a very young age. He studied ornithology at Cambridge before going into teaching. And in 1938, he took a year off from his teaching job to travel to the Galapagos Islands to study Darwin's famous finches there. He got back to the UK just as war was breaking out, and Lack later wrote a short memoir about the early years of his career. So I'm going to read to you a little bit in David Lack's own words about what happened next when he arrives back home in England just as the war was heating up. I had become a pacifist at the age of 17, so he'd signed a pledge to an anti-war organization. And in the autumn of 1940, I decided that I ought to leave my job at the school to work with a pacifist unit. I spent a trial night in the East End of London during heavy raids, but was so put off by the pacifists' earnest attitudes, and so excited by the flashes and bangs, that I was immediately converted from pacifism. A month later, the Central Register for Scientific Workers sent me to interview for an unspecified job. As a biologist, you will of course have learned a lot of physics, the interviewer said. I'm afraid not, I answered. Well, I expect your maths is of a high standard. I'm afraid not. Then, very doubtfully, I fear this job will often entail going out in the wet and cold in the dark. Would you mind that? Not at all. So I was taken on, and 10 days later set off from London with 19 other biologists on a mystery coach tour. It's always fun to discover that the historical person you're writing about had a sense of humor. So, as you might have guessed, David Lack was assigned to a job working on radar systems, because apparently any scientific background was enough to get you a job working on radar systems at this point. He was first sent to the Orkneys, which are a wet, windy, remote group of islands off the north end of Scotland, and I gather he was just about the only person happy to be posted there. because the birding was really good. He got to spend his off hours looking for birds like puffins and skuas. After that, on a tour of radar installations up and down the British coast, he happened to be reintroduced to an old classmate of his from Cambridge named George Varley. Yes, this is our third George for the evening. I promise it's the last one. Again, it was a popular name for mid-century biologists. So Varley, again, had been a classmate of Lack's from Cambridge, and Varley had actually been an entomologist, so a bug scientist before the war, but now he'd fallen into the same line of work as Lack, doing stuff with radar. And it was Varley who actually introduced Lack to the mystery of the so-called angels plaguing the radar operators. Now, David Lack was an ornithologist by training. He was familiar with the behavior of birds in flight, and he pretty much right away was like, guys, it's birds. Nobody believed him. There were tons of skeptics. So Lack and Varley decided to make a project out of this and put their heads together to see if they could prove that this was what was going on. They got pretty creative. At one point, they convinced an officer to tie a dead seagull to a balloon and send it up into the air in front of a radar station, just to prove that it was at least possible for a bird body to produce a radar signal. Finally, in September 1941, they managed to use a powerful telescope to confirm that the source of a signal being tracked offshore in real time was in fact a flock of gannets, the seabird that you see here. As the war continued, Lack and Varley continued to collect radar observations that they believed represented birds. At first, only big birds like gannets and geese were showing up, but the technology was improving really fast, and soon they were detecting things like flocks of little starlings. And so they kept collecting data that confirmed that the characteristics of the so-called angels, like their airspeed and the way they changed direction against the wind, were consistent with the behavior of birds in flight. It took them a while to convince everyone, and so I have one more quick David Lack quote, just because I really like this man's sense of humor. At one meeting, he wrote, after the physicists had again gravely explained that clouds of ions must be responsible, Varley with equal gravity accepted their view, providing that the ions were wrapped in feathers. This guy was snarky. So they stuck with it, and in 1945, as the end of the war neared, they got permission to publish their previously top secret findings in the journal Nature. Today, David Lack, who died in 1973, is better remembered for a book that he wrote about Darwin's finches. But this publication essentially kicked off, as I said earlier, the whole subdiscipline that's now known as radar ornithology. And radar ornithology might have remained a footnote in my book instead of a whole chapter, if not for the fact that after the war, of course, meteorologists also jumped on this and started developing radar technology as a way to provide early warnings about hurricanes and other major storms. Large flocks of birds showed up just as well on weather radar as they had on military radar, and so building a nationwide network of radar stations was great news for ornithologists who wanted to study large-scale migration patterns. This remains, to this day, a really important source of data on these large-scale patterns of bird migration. And so I'm going to give just briefly an example of one relatively recent study that demonstrates the power of this. In 2018, two scientists from the Cornell Lab of Ornithology downloaded radar scans covering every evening across the whole country for the past 23 years, so more than 150,000 individual radar images. And they did some analysis to see how weather factors like temperature, wind, air pressure predicted the appearance of big migration movements on radar. Because migration is a season that goes on for a month or more, but there's not an equal number of birds in the sky each night. There's, big nights and quiet nights. And so they wanted to see if they could figure out, what are the factors that cause some nights to be big and others to be quiet. And so they found that their math looking at these weather factors could explain almost 80% of the variation in migration intensity from one night to the next, and that using this method, they could actually predict several days in advance when these big migratory movements were going to happen. If you've been paying attention, you might notice this is basically the same thing that Lowry and Newman were trying to do with their moon watching data, but now we have much bigger data sets and we have, supercomputers to help us analyze them. So this paper and these predictions were the basis for a really amazing tool called Birdcast that if any of you are birders, you might be familiar with during migration season, which is happening right now. This is still fall migration. You can log onto the Birdcast website and see a forecast of how many birds will be in the skies in your location that night. It's a really, really cool tool. And it is all thanks to a witty science teacher from Devonshire who figured out what must really be going on with those mysterious so-called angels annoying the radar operators guarding England from the Nazis. But radar is not the only way to put radio waves to work tracking birds. And that brings me to my third, final, favorite story that I'm going to share with you this evening after I take a drink of water. All right. This guy, his name is Bill Cochran. This is young Bill Cochran on the left. I actually do have a photo of young Bill Cochran. Bill Cochran later in his career on the right. In the mid-1950s, Bill Cochran was a young Navy veteran working on an electrical engineering degree part-time while also working for a brand new television station based in Champaign, Illinois, where he lived. One morning, he went to check on his employer's transmitter tower on the outskirts of town, and there was a guy there picking up dead birds from the ground. Cochran was like, this is interesting, kind of weird, interesting. And he started peppering this man with questions, asking what he was doing there and why he was interested in these dead birds. It turned out that this man's name was Richard Graber. He was an ornithologist, and he was there because he was studying tower kills, which is the phenomenon where flocks of birds fly into communications towers and are killed by the impact. Cochran was really intrigued, kept conversing with this guy, and pretty soon, Bill Cochran, the engineering student, was spending his spare time tinkering together gadgets to help Richard Graber in his work. Bill Cochran appears in more chapters of my book than any other single researcher. The first project that he and Graber worked on together was, I mentioned briefly at the beginning, the unique calls that songbirds make when they're migrating at night. These are called nocturnal flight calls. These two men were the very first to make recordings of these calls. And so one of my favorite little stories from my whole book is how Bill Cochran, again, who was an engineering student, figured out how to rig up a tape recorder with bicycle axles to hold these 6,000 feet of tape that they would need to record an entire 8-hour night in one go, which is what they wanted to do. But the chapter in my book where Bill Cochran looms, this is Graber with their recording equipment. Sorry, I should have explained what you're looking at here. But the chapter in my book where Bill Cochran looms the largest by far is the one on radio telemetry. So telemetry just means transmitting data from one place to another in real time. And there were two technological advances around this time that helped kick off the field of radio telemetry. The first was the invention of the transistor in 1947. You could see a replica of the first transistor here. To take something very technical and boil it down to the bare minimum, before this, radios relied on bulky, breakable vacuum tubes to amplify the signals that they sent out. They weren't super reliable. Transistors provided a lightweight, efficient, durable way of doing the same thing, and they made it possible to adapt radios for all sorts of tasks that they wouldn't have been suited for before, including transmitting all kinds of sensitive data from one place to another. One of the first groups to start experimenting with this was actually the US Navy, who started trying things like using radio signals to transmit real-time data on a jet pilot's vital signs to someone monitoring them from the ground, and to study the effectiveness of cold water suits for sailors by beaming out temperature data from inside the suit while it was being tested. But it did not take wildlife researchers very long at all to begin borrowing these same techniques. Really, my whole book is just about how good ornithologists are at borrowing advances from other fields of science. So in 1957, some scientists in Antarctica used the system from the cold water suit tests to remotely monitor the temperature of a penguin egg during incubation. That's what's happening here. Those are penguins being manhandled in the lower right-hand corner. That same year, a group of researchers in Maryland borrowed some ideas from the Jet Pilot project and surgically implanted transmitters into woodchucks to monitor their movements in a small nature preserve. Soon, big engineering firms like Honeywell were getting involved in this, trying to design radio tracking systems that they could sell to wildlife biologists to use to track animals' movements. But they were trying things like strapping a metal box containing a radio transmitter onto the back of a grouse and releasing it into the bushes. And a grouse with a large metal box strapped to its back is not going to live very long. So before this was actually really going to take off and become practical, someone was literally going to have to think outside the box. Haha, sorry, I couldn't resist. And that someone was going to be Bill Cochran. Now, I said there were two technological advances. I talked about transistors. The other thing that plays into this is the launch of Sputnik. So Sputnik was launched in 1957, Sputnik 1. It was, of course, the first artificial satellite launched by the Soviets. And basically, all this thing did was orbit the Earth and beep. But if you had a radio and you knew what you were doing, you could pick up this beep from space from anywhere on Earth. And so this thing touched off a whole new wave of fascination with radios and what you could do with them. So by 1960, Bill Cochran, who still had not actually finished that electrical engineering degree, but was apparently something of a transistor savant, if you will, had picked up more part-time work helping a University of Illinois astronomer build radio beacons that were going to be sent up on some of the first US satellites. Actually, some of the first US spy satellites, although they did not know that that's what they were working on. Cochran was also still doing work with Graeber, the ornithologist, and his colleagues over at the Illinois Natural History Survey. And it didn't take long before someone came up with the idea that it might be fun to try combining Cochran's two part-time jobs. Like, hey, Bill, what do you think would happen if we put one of those radio gizmos on, I don't know, a duck? Oh, cool idea. Let's try it. So they sent over a mallard from the field station on the Illinois River. They strapped a transmitter onto this bird using a metal band that went over its chest. And although they hadn't really planned this, it turned out that the bird's breathing distorted the band in a way that affected the radio signal, so that when they released this duck, they found that they could track its respiratory rate as it flew, accidentally collecting the first data on the vital signs of a bird in flight. And they all got a nice little publication out of it. That was the beginning. When that duck took off wearing a transmitter that he had built, something clicked for Bill Cochran, and he knew that this was what he was going to spend the rest of his life doing, was building radio transmitters for wildlife. Now, building a radio transmitter that's going to be worn by a wild animal requires making trade-offs among a long list of factors, because a longer antenna will give you a stronger signal. A bigger battery will give you a longer lasting device, but they both add weight. And Cochran, who would not officially finish that engineering degree for several more years, turned out to be really good at getting this balance just right. He favored designs that were as small and simple and compact as possible. And instead of putting the components in a box, he came up with a way of dipping the whole assembly into plastic resin to seal and waterproof everything together. Okay. So Cochran was building transmitters that were smaller and smaller all the time. He had some early projects helping wildlife biologists who wanted to track animals like rabbits. But by 1965, he was building transmitters small enough that they could be placed on large songbirds. This was great news for his ornithologist friend, Richard Graeber, because Richard Graeber studied thrushes, which are relatively large songbirds, and he was interested in learning more about their migratory behavior. But these devices only had a range of a few miles. So if you wanted to use one to follow a migrating bird, you literally had to follow the migrating bird. So Graeber somehow managed to convince a pilot to try following a migrating radio-tagged thrush at night via small plane. May 1965, they capture a gray-cheeked thrush outside Urbana, Illinois. They trim the feathers from a little patch on its back and they stick on a tiny radio transmitter using eyelash glue, the same stuff we would use to attach false eyelashes, which, side note, is really popular for this sort of thing because it doesn't irritate the skin and it falls off on its own after a while. And so I just love the mental image that I have of generations of like crusty macho wildlife biologists having to learn exactly where the eyelash glue is kept at the local cosmetic store. Anyway, I digress. That night, Graeber and the pilot followed this bird north for 400 miles before turning back, 200 of which were over the open water of Lake Michigan. They couldn't see the bird, of course. They would have just been sitting in the cockpit of the plane, listening to this wavering beep beep through the darkness. Graeber was so awed by this experience and by what this tiny bird was really doing that when he wrote about this later, he compared it to how he felt watching the TV coverage of the Apollo moon missions. And Bill Cochran was just getting started. 1973, Cochran and a student named Charles Welling tagged another thrush passing through Illinois in the spring, and this time they spend a full week following this bird almost 1,000 miles, all the way across the Canadian border and up into Manitoba in a station wagon with a hole cut in the top for the radio receiver. Now, it sounds like they had some wild adventures along the way. As I understand it, at one point, Welling, the student who was along to help drive, basically spent a night in jail when a suspicious police officer pulled them over in rural Minnesota, because who would not be suspicious of this thing driving through your town in rural Minnesota in the middle of the night? Cochran didn't want to stop for too long for fear that he would lose the bird's signal, so he basically kicked Welling out of the car to sort things out, kept on driving until the bird set down around dawn, made a note of where it was so that he could pick it up that evening, doubled back, bailed Welling out again, and on they went. At another point, they both came down with a horrible stomach flu and couldn't find a doctor in the middle of nowhere willing to see these two weird guys on zero notice, so they just kind of toughed it out and kept driving. The only reason they gave up after they crossed into Canada was because the car's engine gave out. As they went, they gathered data each night on the bird's altitude, its airspeed and ground speed, the distance that it covered each night, its heading. And because they were able to stick with this one bird over such a long distance, they were actually able to track how the precise direction that the bird set out in each night changed as its position changed relative to magnetic north, providing some of the first real-world evidence that migrating songbirds use some sort of internal magnetic compass as one of their tools for navigation. And I'm barely scratching the surface of Bill Cochran's stories here. This guy did a lot of stuff like this. Cochran never really got the hang of the politics of academia or of the peer review system for scientific publishing. Remember, this guy was really an engineer, not a biologist. And so he always remained a bit of an outsider. And by the late 1990s, he had left the Illinois Natural History Survey on what I gather were maybe not the friendliest terms. My impression is that he was just a crotchety guy, maybe not the easiest to get along with. He was married 3 times, for one thing. But Bill Cochran kept on building radio systems for ornithologists in his garage right into the beginning of this century. I had the great good fortune to speak to Bill multiple times while I was researching my book, and even to visit him at his home in Illinois, where most of his backyard was taken up with an enormous radio receiver tower, and this station wagon was still in the driveway. He was a hilarious character. He loved to screen his calls by pretending to be a janitor in an animal shelter when he answered the phone. So I would call him at a prearranged time for an interview, like, "Hello, Bill," and sorry, yeah, I'm telling this in the wrong order, but I would call him at a prearranged time for an interview, and he would pick up and go, "Hello, animal shelter, we're closed," and I would be left sitting there like, "Hello, Bill, is that you?" So sadly, Bill passed away in 2022 at the age of 90. I feel really privileged that I got to meet him and get to know him a little bit. I really believe that he is an unsung hero of 20th century science, because although I've only been talking about birds here, if you know, like radio collars for wolves and deer and stuff, all of that goes back to Bill Cochran. And so I'm really happy that my book is hopefully making a few more people aware of the things that he accomplished. Okay, I have been talking for a while. My voice is going to give out pretty soon. I just have a couple more slides, so bear with me. Um, Before I talk a little bit about conservation, I just wanted to mention briefly that I chose historical stories from the book for this talk on purpose because I've given this talk for audiences of ornithologists and I didn't want to find myself talking about someone who was in the audience. That seemed awkward. So I promise that if you get a chance to read the whole book, it is not all dead white guys, to put it bluntly. And in the book, I also cover a lot of the more recent developments in the field, like the latest miniaturized tracking devices, artificial intelligence tools for analyzing big data sets, high volume genomic sequencing, all of this stuff, in addition to profiling, women and people from around the world, all that sort of thing. Thanks to all of these recent high-tech advances, we now have a clearer, more detailed picture of bird migration than we have ever had before. This is good because this data can help us target conservation efforts more effectively. And that is important because migratory birds are not really doing so great. Some of you might have seen some news headlines about this paper back when it was published in 2019. This was called the 3 billion birds paper because this large group of scientists drew on a whole bunch of different sources of data and came up with an estimate that there are 2.9 billion, with a B, fewer breeding birds in North America now than there were in 1970. This is almost a 30% decline. It's just staggering. Researchers and wildlife managers have been scrambling to figure out how to stop the bleeding. And so when it came time to write a concluding chapter for my book and try to tie a bow on this whole thing somehow, I wanted to try to address whether these new tracking technologies might be part of the answer, and also just whether there's any reason for hope when we look at numbers like this. So I called up two of the leading experts on migratory bird conservation today to ask them what they thought. I spoke to Pete Mara, who's one of the senior authors on this paper and a co-founder of the Road to Recovery initiative that grew out of it. He's now at Georgetown University. And I also talked to Jill Deppy, who's the director of the Audubon Society's Migratory Bird Initiative. And I asked them questions like, what is the state of migratory bird conservation today? And are you hopeful for the future? And they had strikingly similar things to say. They agreed that despite all the ever more detailed migration research that's happening now, we still need more data to understand what's behind the declines of many of these species. So their point was that some people might think that it's time to just shift all of our resources from data collection into conservation, but we actually don't know what we need to do to save a lot of these species yet. They agreed that there is a need to get better at consolidating the data that is being collected and get it into the hands of policymakers and conservation activists to get better at working across international borders, to incorporate more partners in the social sciences, more perspectives from Indigenous people. And they both insisted that yes, there is still reason for hope. And so I'm going to conclude by reading a little bit of what Pete Mara said when I asked him if he feels hopeful when he gets up to go to work in the morning. He said, "I'm very optimistic. We've done this in the past, we've corrected other environmental issues, and now we have to deal with climate change. So while it seems like there's this overwhelming deluge of negative issues and challenges with getting people on board with these things and constant pressures on nature, I choose to be optimistic and hopeful just because I don't see any benefit of being pessimistic or having a lack of hope. I just don't choose to take that route. Don't get me wrong," he said. "There are times when I might be negative or spiraling down into a pit of agony, but I'm not going to do that." I thought those were wise words, and I don't know about all of you, but when I find myself spiraling down into a pit of agony, I usually just go birding. So that is what I have for you this evening. I'm going to thank Enlightened Kitsap again for having me. Just real briefly to plug myself a little bit, I am not there in person to sign copies of my book or anything like that, but if anyone is moved to go out and buy a copy of the book after hearing this talk and read the whole thing, that would be fantastic. And I have a bunch of bookplate stickers, so if you buy a copy of the book and you would like to turn it into a signed copy, if you go to my website, which is right here, there's a contact form. Email me, tell me you heard this talk and you bought a copy of the book and give me your address and I'll sign one of those and drop it in the mail for you. One of the questions I get asked very frequently is, are you working on a second book? The answer is no, not at this time, but I do a lot of other freelance writing for magazines about birds and bird conservation and ornithology. And so the other thing, if you're interested in that, the other thing that you'll find at my website is a link to sign up for my monthly email newsletter where I share things that I'm writing and book recommendations, bird news stories from elsewhere. And I guess if I do write a second book, that would be where you would find out about that. So go check those things out. And with that, I would love to take any questions.
Thank you very much, Rebecca. That was lovely. There's several questions here. One is with this significant loss of birds that you say, what is the effect? In other words, does that make more insects or what would be the effect of losing the birds?
I think that's hard to study. Birds do definitely provide a lot of what are called ecosystem services, including eating a lot of insects. That's very true. So birds do eat a lot of pest insects, things like that. So, I mean, I'm sure that there have been ripple effects throughout the ecosystem. I don't think we can really pinpoint it because it seems like it would be a hard thing to collect data on.
There was one question that was already answered there by another person, but they were asking about where do the local ospreys go for their winter when they go away from here?
Yeah, I'm glad someone else asked that. I don't really know necessarily details of where individual populations of specific birds go, but ospreys do migrate quite a long distance, I believe.
Mhm. And one person said it was to North Mexico and to
Yeah.
El Salvador, so that would make sense.
Ospreys are really
Um,
interesting because they're found on, I believe, I think every continent except Antarctica. Ospreys have a very wide distribution around the world. They're kind of fascinating.
it's hard when you go back historically. We've heard like the pigeons covered the earth, they were just from one side of the sky to the other. So there were billions of them. So
The passenger
certainly
pigeons, yeah, or yeah.
passenger pigeons. So again, what's the effect of that one going away? I mean, it's just sort of an interesting thing. There's such a difference between 100 years ago and now,
Yeah.
and then these people that you're talking about, the billion is just from maybe the last 50 years, because that's their measuring range.
Yeah, I'm not an expert on like the ecology of passenger pigeons, although I do find that fascinating. And I know there's a lot of people who are studying that and trying to figure out kind of what the ecological effects of the decline of passenger pigeons was. And again, it's, you can't get in a time machine and go back in time to travel data, so it's a hard question to answer, but there are people out there who are trying to figure that out. Some people even think that that those giant flocks of passenger pigeons might have been a result of like habitat changes created by early European settlers, and that maybe before European settlement of North America, there weren't giant flocks of billions of passenger pigeons. So it's kind of a area of debate. It's a good question.
And it was interesting also when you talked about all the different kinds of sciences that impact upon the measurements of the bird migrations.
Yeah,
That's
I
a
did
good
not
reason.
realize when I started the book that I would be talking to a lot of electrical engineers and computer scientists.
People who don't want to sort of support the sciences in general with money from like National Science Foundation, the point is that you never know where these inventions are going to be
Oh
most
yeah.
used. And this is an example of that.
Yeah. Yeah, and I didn't even talk about like the bird genome project that's the grew out of the human genome project that's used to study bird migration, or like the stable isotope analysis that kind of came out of the field of physics, where you can tell where a bird grew its feathers by how much deuterium is in the feathers. There's all sorts of wild stuff like that.
That's fascinating. Well, I don't see any more questions in the chat group. I think then we're just going to thank you very, very much for giving this wonderful talk. And I think we're going to probably just open our eyes for, we can do our own reading now a little bit more having this background. So
Yeah.
thank you very much.
All right. Yeah, thank you for having me. And like I said, I'm easy to find. There's a contact form at RebeccaHeisman.com that goes right to my inbox. So feel free to
That,
reach out.
that's wonderful. Thanks again. That's really
Yeah.
nice.
Thank you for having me.